Alright, this will be the first of a couple videos on mass spectrometry. So you can do a lot with mass spectrometry. In this course, we're not going to go so in-depth. We're primarily going to use mass spectrometry to determine the molar mass, the formula of a compound, and also to see if we can identify some common fragments that exist in our compound. So what happens inside a mass spectrometer is a compound is vaporized. It's then ionized and undergoes fragmentation. And some of those fragments have charges, and we measure the masses of those charged ions and graph how many of those we detect. Alright, so our sample in the spectrometer enters here, and we heat it up to get it into the gas phase. And then once it's in the gas phase, we bombard it with electrons. When we hit it with electrons, it causes other electrons to be sort of knocked off of the molecule, and so it's ionized, and it breaks up into fragments. Some of those fragments are going to have a charge. And so then we use an electric field to accelerate those charged fragments, and then we pass them through a magnetic field. And so these charged particles are bent by a magnetic field, and that's a general property of a beam of ionized particles. They'll be bent by a magnetic field. The heavier they are, the less they'll be bent by the magnetic field, and the lighter they are, the more they'll be bent by the magnetic field. So if we adjust the magnetic field strength, we can control which ions will make it to the detector. Depending on the strength of the magnetic field, things that are too heavy won't go to the detector. Things that are too light will be bent too much, and so they won't get to the detector. And so then, based on the strength of the magnetic field, we know roughly the masses of the compounds that are making it to the detector. And by varying the magnetic field, we can then look for different masses of these fragments. And then we record how many of each fragment's mass that we detect, and then we can plot that data. So the most common method for ionizing molecules is by electron impact. Basically, we take a high energy beam of electrons, smash those high energy electrons into our molecule, and then it causes other electrons to be knocked off. And we end up with what's called a radical cation. It's a cation because it's lost an electron, and presumably all of the electrons were paired, so it's a radical because it now has an odd number of electrons. This thing is relatively unstable, and so it's going to fall apart or fragment. Right, so this radical cation that we form after bombarding our molecule by electrons is relatively unstable. And so it generally falls apart into a neutral radical and a carbocation. And what we actually measure is the mass to charge ratio of the carbocation fragments that we're able to detect. Now the charge on these is usually 1, so the mass detected is generally the mass of the fragment. We don't actually detect the radicals, but these radical cations can usually fall apart in different ways, and so we'll get a number of different carbocations that result from the fragmentation of our molecule, and by measuring the fragments, they can kind of tell us the pieces that our molecule is made up of. So here's an example of what a mass spectrum looks like. So on the x-axis, this is the mass to charge ratio. Although since the charge is usually 1, this is typically the mass of our fragments. And this particular mass spectrum is the mass spectrum of pentane. And pentane has 6 carbons and 12 hydrogens, so if you add up, the molar mass of that is 72. As you can see, typically the highest peak in the mass spectrum is the molar mass of the compound. And so this is basically pentane with a positive charge. It hasn't fallen apart. And then these other fragments are what we detect when we essentially chop off pieces of the molecule due to the fragmentation. And the higher the peaks, the more of that particular fragment we've detected. And so in the next video, we'll talk a little bit more about how we analyze the mass spectrum.